Good noon, everyone. I'm Joan Chen. I come from Taiwan, and I'm a postdoc in NCKU. This paper is titled Drug Replication System based on Deep Learning Multi-Scale Rotating Re-encode Detector and Feature Embedding. The others are Joan Chen, Zheng Bang, and Junfa Wang. I'm the speaker, Joan Chen. And this is our outline, including introduction, related work, the proposed system, experiment, and conclusion. And the first is the introduction. The Institute of Medicine has reported that medication errors are the single most common types of errors in healthcare, representing 19% of all advanced events, when accounting for over 7,000 deaths annually. In ICU, medication errors account for 78% of serious medical errors. The fatigue and stress of long-term shift undertaken by nurses working in the ICU are potential contributing factors to medication errors. A variety of possible causes the medication errors: similar appearance, similar drug names. The same drug is composed of different formulas. There are certain difficult to handle: multi-type package, multi-type feature space, multiple placement position, and encores. Therefore, we hope to solve the problems through the proposed system. The next is related works. Young scanned the barcode to identify drugs, and there are almost no errors. The barcode must face the camera. John extracted drug in ROI based on age detection and used classifier to identify drug, but they cannot be many categories. And Gang used OCR and shift to match imaging, but they have to make sure that the label faces the camera and is placed upright on the belt. And they use VGG19 deep learning neural network, but there are only 11 types. And team use YOLO deep learning technology, and it's only for Blaze pack. And then is the proposed system. The proposed system architecture is shown in the figure. The system consists of two stages. The first stage is drug detection system based on deep residual network, and the second stage is drug matching system based on feature embedding. In the first part, we obtain feature maps of different scales from the input imaging dataset, and we use feature pyramid network to merge features of various scales, and we use confidence module and regression module for each feature map. And in the second part, we use the feature embedding network to extract features from the input data, and we can obtain embedding features, and then we compare the two distance of geometric feature and embedding feature respectively. Finally, the results and expected category are input the decision matrix module to determine whether the input drug image pass or not. And here is an example. And we can see a medicine on the screen, and there are three prediction boxes: yellow, red, and blue. And the yellow one is the highest confident. And through this alignment, we can get a image a picture without the background and the character position and the correct angle. And the picture on the left is the architecture of our feature embedding. The input image will output embedding feature after 4 identical blocks, and the structure of the blocks is shown in the right. It consists of a 3x3 convolution layer and batch normalization layer, reduce and mask pooling layer. And now we go into the experiment. The dataset we use on the verification test is shown in this page. We can see the camera type, resolution, and categories, detection database, and matching dataset. We place the medical with random position and angle. And here are 10 pictures are example of matching dataset. There were cropped after detection system. And those are parameters of our experimental, including accelerator, pre-trained model, iterations, and learning rate. And we use averaging position to evaluate our model. We compare with other algorithms, the R2CLN and SCR data, and we can see some errors in those algorithms. Some are angles and bounding box errors. And as a result, we get a high accuracy rate of 99.21% when we use ResNet 50. It can conclude that we use FPN architecture to combine multi-scale feature map and general-rich semantic feature maps. And the table is the result. The results show that our model can get higher accuracy rate, and the method of refining multiple categories for feature embedding during training can improve the accuracy. And now we are going to conclusions. Our detection system is an anchor-based detector based on deep learning neural network and use FPN to combine multiple semantic feature maps to detect multi-scale drugs. It can detect drugs at any position, any placement angle, and any placement surface. With axis alignment and multi-class training method, our matching system can identify drugs at any position, any placement angle, and other conditions. With the two systems, our drug verification system can achieve 99% accuracy. And these are following reference. Thank you for your listening. I'm John Chen, and this is my content information. If you have any questions, please be free to contact me in email or line. Thank you.